Hello, welcome to another tutorial. In this video, we'll be going over how to calibrate your new tool for your AUBO Cobot. So let's just say you get a new tool, for example, a gripper. You're going to need to do some kinematics and dynamics calibration on it before you can make proper use of it. So to do so, you're going to need to go into settings, tool cal, and then let's start off with kinematics calibration. Now there are kind of two ways to do this. One way is the most common way. Let's just say you buy a gripper or any sort of tool. You will have the tool center point coordinates, your X, Y, Z, RX, RY, and RZ. You're going to have the coordinates of these. So you can just enter it here. However, if you kind of make a tool by yourself, so you don't have these exact coordinates and measurements, you're going to have to manually calibrate your tool. And we have a video going through how to do this manually, so please feel free to check that out. So today, assuming you have the dimensions of your tool, right, and you know where your tool center point is, you can go ahead and enter it here. So to get started, kinematics name, let's say today we're using the Shunk EGPC gripper. And this tool center point is all with respect to the flange center. So there's no offset at all in the X direction and in the Y direction. So the change is only along the Z direction. So we have an offset of 0.163 meters in the Z direction, sorry. And let's just assume our X and our Y, our Z are all 0, and the axes, the X, Y, Z axes of this tool are fully aligned to that of the flange center. So however, if your tool is different, you feel free to change any of these numbers. This is just the specific set of numbers for my tool that I'm using here. So go ahead and click Add. There we go. So you have Shunk EGPC here. So now let's calibrate for our dynamics. So in the dynamics, you're going to need to look at your payload and where the gravity center is. So the gravity center is different from the tool center point. So the tool center point is the point in the center of your fingers, your tool fingers. However, this gravity center is the center of mass. So let's go ahead and type in Shunk EGPC as the name. Payload, roughly 6 kilogram. Gravity center is not offset at all in the X and Y direction. Again, this is with respect to the flange center. However, it is offset in the Z direction by 0.00562. Click Add. Now, finally go to Tool Cal. This is where we finalize the calibration. Let's name our tool Shunk EGPC. Kinematics is Shunk EGPC Kinematics, and Dynamics is Shunk EGPC Dynamics. Click Add. There you go. You have completed calibrating for your new tool. So let's test it out. So normally, your target is the flange center as the base, right? And when you do orientation control, you'll see that the flange center doesn't move. However, everywhere else on the robot is moving. So if you just look at the tool center point, when I do some orientation control, you can clearly see that the tool center point is indeed moving, right? However, let's say we set Shunk EGPC as the target. Now what should happen is that once I do orientation control, this TCP, the tool center point, should not be moving at all. And there you go. As you can see here, as I change the orientation, the tool center point is not moving at all. It's staying in place. The robot is kind of like rotating about this tool center point here. There we go. So we have successfully set up and calibrated our new Shunk EGPC tool.